Good evening, everyone, and welcome back to Fundamentals of Engineering with Farhad. Mechanics of Materials, Calculation of Shear Stress. So, in this configuration, we want to calculate the maximum shear stress in pin B if we do know that all pins are in double shear condition and also the diameter of pin B is provided to be 6 millimeters. So, in our problem statement, it says all the pins like pin at B, C, and D are in double shear condition. We want to calculate in part A the axial force in member CD and also in part B the average shear stress in pin B if we do know that's in the double shear condition and also the diameter of pin is provided to be 6 millimeters. So to start our problem, let's jump to the first part, which is the calculation of force in the member CD. So for calculating the axial force in member CD, we can start with the summation of moment about B goes zero. A counterclockwise is a positive, arbitrary positive direction, and then we have like FCD times 300 millimeters times the sine of 45 degrees, the vertical distance from the force FCD to the point D, minus a 3000 Newton, which is our P provided, times 450, which is the distance between force and the pin B. So in this equation, FCD is equal to 6,363.96 newtons. As soon as we have FCD, our first part is solved. Now for average shear stress in pin B, we do know we do need the both component of force B. So that's like Bx and By. So if we already calculated the axial force in rod CD, so we do know that the horizontal component of B is equal to, because these two forces should cancel out each other, so it just says Bx is equal to FCD. Likewise, if you jot down the summation of forces in y goes zero, it just simply says By is equal to the downward force P, which is 3000 Newton. So as soon as we have both component of B, like Bx and By, we can calculate the resultant force at B, and that's nothing but a square root of Bx squared plus By squared, a square root of that, and it just gives us the total force in B is equal to almost 7,000. If we have the force in P in B, now the shear stress in P in B is equal to, because that's a double shear, you can either use the force over 2 B over 2, or use the 2 of area. Whatever you are more comfortable with, the result is the same. So the B over 2 is due to double shear nature at P and B, and area of the pin is provided pi times d squared, 1/4 of pi d squared, which is provided. If you do the math, it just gives you the amount of shear stress at P and B. So our problem, initially the problem statements were looking for the force in rod CD, which is part A, and also in part B, tau at B is equal to 124.42 megapascal. Thank you. We'll solve more problems related to free body diagrams.